Hello and welcome to The Road to Net Zero, a podcast from the Advanced Propulsion Centre. My name is Clem Silverman, and in this episode I'm taking you back to last year's LCV exhibition, during which I spoke to Dr. Sarah Ridley about Autocraft's new off-grid portable solution to repairing EV batteries. It's come out of the RECOVAS collaborative project led by EMR, European Metal Recycling, aiming to create a circular supply chain for electric vehicles in the UK and addressing some of the myths that still persist around the recyclability of batteries. EMR are working on the process to recover the critical materials and elements from used battery packs, with some amazing progress being made on that front. But Autocraft have created a novel way of servicing and repairing EV batteries to get them back on the road, or removed from a vehicle, repaired and remanufactured to be available as a spare in the future. So let's head back to last year and to find out more about this. I'm standing here outside on the steering pad at LCV with Autocraft, who have this amazing pod which has come off the back of a lorry. It's black and it's whirring away, and I'm wondering what's inside it. And I've got with me Dr. Sarah Ridley, who can explain a little bit more about it. But Sarah, can you introduce yourself and say who you are and what you do?
Hello, I'm Sarah Ridley. I'm the Engineering Quality Director for Autocraft Solutions Group, and so I'm really responsible for delivering all the clever things our research and development department create and have ideas for. And
this bit of kit looks very clever. I understand it's an output or part of an output from the RECOVAS project, which is an APC-funded collaborative research and development project. Just explain to me what you've got on show here and the benefits that it brings to the automotive industry.
Well, the shiny back trailer that you just discussed, our pod, is actually effectively a factory in a box. So what we can do is we can go to anywhere that EV batteries are, and we can repair them. We can do a complete diagnostic test. We can take them apart. We can replace what needs to be replaced, having first balanced it to make sure it fits in with the pack. And then we can give it a certificate of health and a complete status once it's been put back together. And that's really important, because what it's doing is it's stopping EV batteries having to go straight for recycling. At the moment, as far as we're aware, we're the only people who can do that. And because the population of EV vehicles is quite sparse and quite widespread, we can go to the batteries, which means that we haven't got all the worry about transporting dangerous goods and all the things that are involved there.
Because one of the myths, I think, around EVs is that batteries are going into landfill and they don't last, and you can't repair them, but you can repair them. And I understand that one of the things that you can do inside here is actually identify which part of the pack maybe has failed and extract it somehow and then repair it and put it back in the car. Is that correct?
That's completely correct. Now, in fairness, there are some batteries that we can't repair, and that's to do with the way they're designed. But RECOVAS, which is the project that's been funded, actually is looking at how we design to make them repairable, and that's really important, because theoretically it's a bit like a broom. You can replace the handle, you can replace the head, and you can keep it going forever, and you can do that with EV batteries as well. They're made up of cells and modules, and we can detect down to cell level which one isn't performing correctly. Or it might be something as simple as a broken connector, but we can detect that too. And then that tells us exactly what we need to repair. And our system will actually bring the battery in and present it in the right orientation to allow it to be safely repaired. We have all kinds of safety systems built into there, which mean that we won't operate our system unless the camera knows that the operator has the correct PPE on. We've tested it. If you even take off one part of your PPE, even your glasses, it stops. If you haven't got the right tool, it won't work. If you're not in the right location, it won't work. So even somebody standing in the wrong location will stop the system down, and that's all designed to protect the operator. But what it means is we can give EV batteries life that goes on way beyond what it was originally designed to do. And I think that's also important for our circular economy, because it makes it accessible for people who want to buy a second-hand EV. You're not going into the unknown there. So much of the value in the car is in the battery pack. If you then can repair it, and you know you can continue to repair it, it's worth buying. Whereas if you've got something that you think has to go into landfill or won't be repaired, the worry always is you're buying one and it will be too expensive and it will be written off. And I think that leads me on to the next thing that's really good. And again, a big part of this project is that insurers have no way currently of gauging whether an EV car that's been in a crash or in some kind of incident actually is repairable. And so often they're written off without any kind of investigation, and we can actually go out with a mobile solution even before we get to the point of repairing and give the insurers a really good idea of what's wrong with it and whether it can be repaired. And that means that so many fewer will need to be written off, and I think that's hugely important.
And it really is mobile, isn't it? So
totally and utterly mobile.
Is this one here off-grid as well?
All of our solutions are completely off-grid. So you can plug them in if you wish, but they are completely working off-grid. So actually, literally what happens is we put everything inside the container, we close it up, it has legs on hydraulic rams that stand up, our lorry reverses in underneath it, it drops down, and then it's off to its next site. And we can literally deploy it in around about 40 minutes.
Some Thunderbird stuff, isn't it?
It is. Its nickname is Thunderbird. I'm not allowed to call it that officially, but its nickname when we've been developing it has been
What do you call it officially, actually?
It is actually the Revive Mobile Repair Centre.
Fantastic. And just explain a little bit briefly around what the funding has enabled you to do that you might not have been able to do otherwise.
We're an independent remanufacturer, so we are not part of a big group. We're owned by private shareholders, and whilst that means we can be really agile and we can think wonderful things, actually to go to market with something so unknown, to look for money to back us, is very difficult. APC funding has meant that we could actually set our development team going and say, right, how do we make this the best it can be? And we've had 6 patents from this. We are now in market. We have OEM manufacturers, so not just vehicle OEMs, but pack OEM manufacturers who are looking to us, and we are about to deploy this on the continent so that we can open a centre on the continent to deal with European EV batteries, because we are the first to market, and we're the first to market because of the APC funding, because it's so difficult to get private funding for things that are unknown. And I don't blame people. When you go to them with an idea that you can do this, like you say, out there people think, oh well, they can't be repaired, they have to be scrapped. It's very hard then, but APC has really facilitated that, and it's been marvellous.
Oh, fantastic. Okay, and so in a year's time, come the next LCV, what might we be talking about then in terms of for this solution?
Okay, so our solutions currently have all been outside of the vehicle. And what we are doing now is extending that with the APC projects into in-vehicle. We want to be able to facilitate dealers, repairers, insurers to be able to literally plug our system in while the battery is in the car and be able to tell the consumer exactly what there is. And we have lots and lots of hours of testing, millions of hours of testing. So we have algorithms, and we can actually say, if you replace these things, it will give you this much life, whether that's in terms of range or kilowatt hours. We can do both. And then that will enable consumers to make the choice about what's value for money for them, which means that repairing then, again, comes on a bit of a leap and a bound a bit further, and it will also help things like insurance as well. We can also, we believe, be able to give people tips about how to extend the length of their battery in terms of charging and use, and that will also go forward and help them to be able to get the most out of it as well.
Thank you very much for your time. Thank you.
You're welcome. Absolute pleasure.
Anything else you'd like to add?
What I would say actually is to anybody who's thinking about it out there, if there is an APC project you want to be involved with, do it, because it's been marvellous for us. Really marvellous. It's true though, I mean genuinely, because we are independent, to actually go and move into something that is so out there, getting funding for it when you're not a big company is really difficult. So APC has facilitated things that we wouldn't have been able to do otherwise.
Yeah, lovely. Thank you so much.
No, you're welcome.
And if you want to know more about our collaborative research and development programme and competition, head over to the APC website to see what the next opportunity might be. Thanks for listening to this episode. Stay subscribed to hear more of our projects and the work of the Advanced Propulsion Centre.